So if we have a friction force here from this point A to point C, so what is this condition called as static? And for static, your friction force is simply given by mu times n. Whereas this condition from C, or we'll say this one is D and this one is E, this is called as dynamic condition. Dynamic means that a body is accelerating with acceleration equal to A. So for this one, the friction force is given by mu k times n. But if your value is here, so this is simply given by mu n, whereas this value is called as maximum value of friction, and this value is given by mu s time n. And this is a very useful concept. This point is very useful. Now what you do is that whether your plane is horizontal or your plane is inclined, it doesn't matter. If your object is like this or your object is on the inclined plane, identify the number of forces acting on this one. There is a string, there is a pool, some normal reaction like this, and let's say that this is the net force acting. After all calculation, we are getting the net force. Is this net force is parallel to the plane, and therefore is this force is responsible to move this body on this plane. Now once you do this job, then you independently find out the value of F max. What is the value of F max? Is mu s multiplied by n. Now compare this value of F max with F net. One chance is that your F net is less than F max. If this is so, it means that you are in a static condition and you are somewhere between A and C. Since you are between A and C, your F net is not sufficient to overcome friction force. So F net itself is equals to friction force, and that is equal to mu n. And you can find out the missing value of coefficient of friction. The second case is that F net is almost equal to F max. This is called as on the verge of motion, and this is exactly the point C, or is also called as impending motion. And for this case, the F max is equals to mu s time n. And third case, the F net if greater than F max means you have crossed this limit. If you have crossed this one, is equal to ma, is equal to ma. We have given a block of 200 Newton and it rests on horizontal surface. It requires a horizontal force of 120 Newton to start moving and a horizontal force of 20 Newton to slide it at a uniform speed. Determine the coefficient of static and kinetic friction. The weight of the block is given as 200 Newton. So the normal reaction is also equals to 200 Newton. In the first case, we are applying the force of 120 Newton. He says that to move the block we required 120, and once it is motion, once it comes in motion, to maintain the motion, how much velocity, how much force required? 90 Newton हो जाएगा. So for second case, If we apply a force of 90 Newton, in that case it's a motion, the block in motion. If the block is in motion, mu will be equals to mu k. So we have again P equals to the frictional force, but this time frictional force is 90. Normal reaction does not change. So coefficient of kinetic friction will be equals to 0.45. Coefficient of kinetic friction is always less than the coefficient of static friction. So the weight of the block is given as 981. That will act through center of gravity. The normal reaction will act vertically upward. Let's say normal reaction is N. If we apply sigma Fy right now, so tension is positive, 981 is negative. So what is the normal reaction N? That will be 981 minus T. Now it is a case of just able, that is a impending motion. For impending motion, the external force F must overcome static friction. That is the minimum force required. Coefficient of friction is given as 0.2. Normal reaction is 981 minus T. So T will be equals to 481. So wardrobe is 100 kg, height is 4 meter, width is 2 meter, and the depth perpendicular to the plane is 1 meter. Is symmetric about y-axis, stands on a rough level floor as shown in the figure. A force P is applied at the mid height. At the mid height, so this distance is 4, so this equals to 2 meter. So as to tip it about the point Q. So there is a tipping occur at point Q. Point Q is here. What are the minimum values of the force P and the static coefficient of friction mu s between the floor and the wardrobe? This is a GATE 2014 question again. So if you apply the force P, it will topple about point Q as shown in this figure, but do not use this figure for calculation. Use the original figure. Since we have a contact at point Q only, so show the normal reaction at N. The weight of this one will always act through center, and the weight is 100 kg. So this is 100 multiplied by 9.81. Since it's going to topple on this side, so friction force will be like this. So as far as this figure is concerned, you can apply sigma Fy. 981 is downward force, and the normal is 981 is downward and normal is upward. So normal will be equals to, and if you apply sigma Fx, then the P will be balanced by friction force. So value of P will be, coefficient of static friction is given as equation number 1. Now we'll take the moment about point Q. So what is the moment of P about point Q? Is a clockwise and a perpendicular distance is 2. What is the moment of weight? 981 is anticlockwise and the perpendicular distance is 1. So moment of force P into 2 minus 981 into 1, these are the only two quantity. Moment of friction force and normal reaction is 0. So value of P is 490.5. And now you put this value back into equation 1. So this is 490.5 minus mu s. Normal reaction is 981. So value of mu s will be 0.5. So choice A is the correct choice. The coefficient of friction of the wood over a stone is 0.6. How heavy a wooden box can be pulled over a stone floor with a horizontal force of 180 Newton. You need to find out weight of the block. So show the weight, normal reaction, external force and the friction. The weight is W. So normal reaction is same as W. The maximum value of friction force is mu s into n. Mu s is given as 0.6 times W. External force you are applying equals to 180. So we can apply sigma fx equals to 0. So 180 minus 0.6 time W equal to 0. So is W equals to 300. To maintain the uniform speed, then you always get a value of what? Kinetic friction. A block, the weight of the block is 125. Normal reaction is same as 125. External force is 75. The block is in motion. What is the meaning of uniform speed? Newton. This one is 125 Newton. This one is normal reaction N is same as 125. This one is friction force. It's a static or dynamic condition. It's a dynamic condition. U is equals to V. So V is equals to U minus 80. So A is always equals to 0. So what about the inertia force? Will the inertia force will act or the inertia force will be equal to 0? Inertia force will be equals to 0. So we have a simple balance of sigma fx, that is a 75 is positive, minus mu k into normal reaction is 125. So coefficient of friction is 0.6. A block of stone is pulled over a horizontal surface by a pull of 1550 Newton at an angle of 10 degree to the horizontal. If the coefficient of friction for the surface is 0.55, what is the weight of the stone? If the center of gravity is like this, is the pull is applied like this way. Acha, pull. Will you apply the pull on this side or will you apply the pull on this side? You want to move this block. So will you apply the pull like this or will you going to apply like this? Always upward. How much is this angle? This angle is 10 degree. What is the weight of this stone. You want to find out the weight of the stone. So let's say the weight of the block is W, normal reaction is N, this force is 1550. Can we resolve this force into two components? One component will be like this, is 1550 into cos of 10, and one component of this one will act vertically upward, and this component will be 1550 into sine of 10. What is the coefficient of friction is given to you. So friction force will act opposite to this, and this value was friction force is mu s time n. So friction force will be 0.55 times n. Whenever you are working in the friction problem, you apply sigma Fy first, that by default perpendicular to plane. So 1550 sine 10 minus W minus N, or N equals to W minus 1550 sine of 10, the sigma Fx equation. The 1550 cos of 10 is a positive value, whereas the only force acting in the opposite side is a friction force, is 0.55 times n. So if you solve this equation, your answer is W equals to 3044 Newton. A machine weighing 3 kilonewton is resting on a horizontal surface. A force of 750 Newton is applied by means of a rope at an angle of 20 degree above the horizontal. Is able to move the machine. Calculate the value of coefficient of friction. This time force is given, and we need to find out value of mu. Is able to move, so it is on the verge of motion. So this one is the center of gravity. Through this, the weight will act vertically downward. The weight is equals to 3000 Newton. A rope is connected, and the rope makes an angle of 20 degree, and we are applying a force of 750 Newton. So we can resolve this external force as 750 cos 20 and the other one is 750 sin 20. The normal reaction will act vertically upward, and the coefficient of friction is mu s into n. The block is on the verge of motion. As a standard practice, first of all you have to apply sigma Fy. So 750 multiplied by sin 20 minus 3000 plus n equal to 0. Now apply sigma Fx. For sigma Fx, 750 cos 20 is positive value minus mu s into n, 2743.5. So value of mu s equals to, so coefficient of friction is 0.2. The parallel component is sin cos theta. So this one is horizontal component. The parallel to plane is W sin theta. Vertical component is W cos theta. So reaction is perpendicular to plane. So reaction is same as W cos theta. Naturally the block will try to move in a downward direction, so the friction force will act opposite to motion. This is the problem of dynamics. So the friction force will be mu times N. Sigma Fi we already done here, we have already done and we have shown the friction force. This direction is X and this direction is Y. Sigma Fy we already balance. Now we need to balance sigma Fx equals to 0. So W sin theta is a minus value as per this arrow. The friction force is minus or plus, is plus mu times N. Motion is this direction, so will the inertia will act opposite direction, and is inertia will be ma. So inertia force will be ma. Inertia force always act in a direction opposite to motion. So we get minus W sin theta, and this one is plus mu. Can we write mu is equal to tan? Cancel W, this W and this W is cancel out. Minus sin theta will become the sin theta on that side. This is plus mu is simply sin theta minus mu cos theta, and either you take sin theta or cos theta. So in number of terms there is a tan theta. So what we'll do, shall we divide by cos theta, that is we'll take cos theta common. So if you take cos theta common, it will be sin theta by cos theta, that will be equal to tan theta minus mu. But one term we have missed here, that equal to what? G. So we have an equation V is equals to U plus AT. Another equation is V square equal to U square plus twice AS. And the last equation is S equal to UT plus half AT square. We don't know the final velocity, so we'll go for the last equation. So the total distance between this is S. U is initial velocity is 0 plus 1 by 2. Acceleration we have just find out is cos theta multiplied by tan theta minus mu multiplied by G multiplied by T square. So we have T is equals to 2 times of S divided by G multiplied by cos theta multiplied by tan theta minus mu, and whole thing in the under root sign. So which is the correct choice? So we have a given data like this. The mu s is given as 0.4, mu k equals to 0.2, as far as 10 second is concerned. So this graph gives you the idea of the P versus T. It was linearly increasing at T equal to 10 seconds. The value will be equals to So force required to move the block will be Ff max equals to mu s into n, that is 0.4 into 200 will be 80 Newton. At T equal to 10, the value of external force will be 10 into 10 equal to 100, and this value of force is more than Ff max. So the block is in motion, and therefore the permissible value of friction force is mu k into n, and mu k will be equals to 0.2. Normal reaction is 200, so this value is fixed, that equal to 40. The block is in motion, so we have D'Alembert principle, that is F net equal to mass into acceleration. F net will be P minus the friction force, that equals to 40. Is it correct? Must equal to mass. The mass is 200 divided by G, 9.81. 200 Newton is a weight, so 200 divided by 9.81, and acceleration we are going to write down as dV by dt. This is a simple differential equation, so we will separate the variable and we will get dV equals to, now P will be equals to what? 10 times T minus 40 multiplied by dt, and this value is 200 divided by 9.81. Now we will put up the limit of integration at T. Getting the motion from 8 seconds onward. That is why the limit is from 8 to 10, 0 to V. So final answer is 4.9 meter per second.